Number 6, a restaurant owner orders a replacement set of knives, forks, and spoons. The box arrives containing 40 utensils and weighing 141.3 ounces. A knife, fork, and spoon weigh 3.9, 3.6, and 3 ounces respectively. How many solutions are there for the number of knives, forks, and spoons in the box? Okay, so you can read this through one time and you can pick out some information, but I think that the place to start is at the end. That question right there, how many solutions are there for the number of knives, forks, and spoons? I'm looking at, it looks like I'm finding the number of knives, forks, and spoons right here. When I see that question, I immediately know there are 3 variables. I wouldn't name them X, Y, and Z. I suppose you could, but I like those letters because they're descriptive. So I would recommend you pick something like that, K, F, S. So what's weird about this question is it doesn't say how many knives, forks, and spoons. It says how many solutions are there. And so that kind of hints that there's a twist to this problem. But anyway, let's just solve it. Let's see where it takes us. So after we identify the variables like this and we know what we're finding, I would go back through and see if any equations jump out at us. We'll see a lot of repetitive kind of patterns. And when I read this and I see this 40 utensils, a box arrives containing 40 utensils, you should recognize a number like that as a total. That's the total number of knives, forks, and spoons. And so that's an equation. Number of knives plus the number of forks plus the number of spoons is 40. That's one of my equations. Then I see this number weighing 141.3 ounces. That's another total. That's the total weight of the items, right? And so you see all of these numbers right here. You should be able to just say that's the weight of a knife, that's the weight of a fork, that's the weight of a spoon, and you should be able to pick out an equation based off of the weights. And so when I write this down, keep in mind when we deal with matrices, we're dealing with rows and columns. So try really hard to line up your K, F, S, and constant, all right? So I'm gonna put 3.9K and plus 3.6F plus 3S equals 141.3. Now this problem is super complicated. I don't see any other equations. I'm going to do a shortcut on this, but I don't see any other equations. And so you might notice if we tried to do triangular form, there's nothing here in this last position. Okay, specifically, what you should notice, if there are 3 variables, we're going to need at least that many equations in order to have a solution. So when you've got 3 variables but only 2 equations, that's a pretty good indication that this is going to be many solutions. All right, so this is going to be many solutions, and I'm going to tell you right now. I'm going to shortcut through all of the steps, and I'm going to go right to the end and tell you that, yeah, this is many solutions. So starting tomorrow or next day, I'll show you how to use some technology. But for now, let's just say we do that echelon method, and we end up with K plus F plus S equals 40. And then once we do the echelon method, we get dot and F plus 3S equals 49. So again, I'm kind of skipping over the work. You can see though, it's going to be many solutions. And remember the question, it says how many solutions? So it's not going to be an infinite number. If you think about it, there are limitations on this problem. 40 utensils, any number that produces like a negative number of forks isn't going to work. Any number that produces like a decimal number isn't going to work. There are some restrictions. The 3 numbers are going to have to add up to 40, so any solution to this equation or system that produces a number bigger than 40 isn't going to work. So there's a limited number of solutions, and that's kind of our job, is to figure out how many. Now, we're going to use this idea of parameter here, okay? We're going to use this idea of parameter to come up for format. So how this is going to work is typically we will think about an ordered, in this case, triple. But usually what you want to do is keep the last variable. So we're going to let the last variable be S for spoons. But what we want is we want the first and the second one in terms of that variable. We want everything in the same term. And we can do this. All right, we look at the second equation. If you notice the second equation, if we just like ISO the F, we would get F equals 49 minus 3S. So the number of forks is 49 minus 3S. I'm going to put that right here, 49 minus 3S. And so I know that's kind of tricky, but what that means is pick a number. Let's say there are 5 spoons. If there are 5 spoons, then plug in 5 for S, and you'd have 49 minus 15 is 34 forks. And so we can kind of figure that out based off of this parameter. And this parameter works by putting all 3 of the variables in the same terms. I want them all in terms of S. So now the top one's kind of tricky because there's a lot going on. We want K in terms of S. And so we've got S over here, that's fine. But this F, we would want to use what we just had here, 49 minus 3S. 49 minus 3S. And so I'm going to go over here and rewrite that equation. That equation would say K plus 49 minus 3S plus S equals 40. I know that's super complicated looking. I can combine some like terms. K plus 49 minus 2S equals 40. And basically what I'm going to do is I'm going to subtract this 49 over, just trying to ISO the variable, and I'm going to add 2S over. And so I end up with K equals, I've got 40 minus 49 right here is negative 9 plus the 2S. Or let's write it backwards and say 2S minus 9. That is the general form of the solution, but that doesn't answer the question. The question was, how many solutions are there? How many solutions are there? And so that's why I want to use a spreadsheet, okay? We could do this by hand, but it would take kind of a long time. So check out what I can do with the spreadsheet. We've got K for knives, F for forks, and S for spoons. All right. And so if you go back and you look at your solution, the number of knives is 2S minus 9. So 2S, 2 times the number of spoons minus 9. So what I'm going to do under here is say equals 2 times, this would be the number of spoons, minus 9. Okay, so right now that says minus 9 because it's assumed that this is 0. But if I put that as 5 or 8 or whatever. So let's look at the number of forks. The number of forks says 49 minus 3 times the number of spoons. So I'm going to do equals 49 minus 3 times the number of spoons. Okay? So I can copy this down and find other possible solutions, but you notice some of them are negative, and those aren't going to work. Okay, so watch what I'm going to do. Let's copy this down a whole bunch of times. And obviously we don't want negatives. Let's start with the lowest number of spoons could possibly be 0. That's not going to be good because that's negative 1. That's not good because I can't have negative 7. 2. Actually, let's copy this down. Anything you see with a negative value is going to be bad. So we look, this is really the first solution. We already came up with that. 5 spoons, 34 forks, and 1 knife. That's one of my possible solutions. As you look through, as soon as you get to here, you start seeing some negative numbers. Those are all going to be bad news. Those can't possibly work. So we're left with these are the only ones that would possibly work. These are a bunch of solutions. So count them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible solutions, and that's the answer to that question. How many solutions are there? There are 12. Hang on, not done. We haven't done part B yet. Part B says find the solution with the smallest number of spoons. Well, that's easy now, right? Because these are the only possible solutions. So the solution with the smallest number of spoons is right there, right? 1 knife, 34 forks, and 5 spoons. 1 knife, 34 forks, and 5 spoons.